Okay, chapter review. We have 3 chapter reviews. For chapter 8, it's such an important chapter. We really need to get this out of the way. As the coming chapters, you're going to be integrating non-stop and in the next course as well. So, I'm looking at the chapter review, and this is on page 533. Alright, well, number 2, if I glance at it, I notice there's a log in it, so I already know how this is going to work. I'm going to let u equal natural log of x. If u does it, good work. If not, well, obviously it doesn't work because this is my u. I still have an x squared dx. That means parts. With natural log, any log, or inverse trig functions, that's how it works. And if I integrate, I get v to be x cubed over 3. This is going to be u times v minus the integral, and if I multiply those, I'll get a 1/3 up front and x squared dx. That would be x cubed over 3 natural log of x minus 1/3, and this would be add 1 to the power, divide by that, don't forget the c, and that's good enough. Next problem up, I notice this is a fraction and this is an improper fraction. So we're going to proceed with long division. So this is actually x cubed plus 1 divided by x cubed minus x, that's 1. And that would be x cubed minus x. Subtract means change both signs. And that means this is the integral of 1 plus x plus 1 over, and I could factor an x out of that. That would be x squared minus 1. You know what? Let me write it out. So that is the integral of 1 plus x plus 1 over x into x minus 1 into x plus 1. And those cancel out. So that would be the integral of 1 plus, and we need to figure out what 1 over x into x minus 1 equal. That is a over x plus b over x minus 1. So 1 equal a into x minus 1 plus b into x, that's it. If I let x equal 0, I'll get 1 to equal a times negative 1, so a is negative 1. And if I let x equal 1, I'll get 1 to equal, that would be a 0, plus b, so b is 1. So this is plus 1 over x minus 1 minus 1 over x dx. That turns out to be x plus natural log absolute value of x minus 1 minus natural log absolute value of x. You could combine the logs again. You don't have to on a test. That's a fine answer. Next problem up is number 18, and I noticed that this is already set up for partial fraction decomposition. So that's going to be a over v minus 1 plus b over v minus 2 plus c over v minus 3. So if I clear the fractions, 3v minus 7 will equal a into v minus 2 into v minus 3 plus b into v minus 1 into v minus 3 plus c into v minus 1 into v minus 2. I let x equal 1, let v equal 1. 3 minus 7 is a negative 4. A 1 in there will give me a negative 1 and a negative 2. That would be a 0, and that would be a 0. So automatically a will equal negative 4 divided by 2, which is 2. Got it? I let v equal 2. 6 minus 7 is negative 1. That is a, if I put, actually no need to put it there, because if I put a 2 right there, that's a 0. If I put a 2 in for those two, that would be a 1, and that would be a negative 1, and that would be a 0. Automatically, that means b equal a 1. And if I let v equal 3, 9 minus 7 is a 2. A 3 in there, that's a 0. A 3 in there, that's a 0. And a 3 in there, that will be c times 3 minus 1 is a 2. And 3 minus 2 is a 1. That means c is 1. So basically, I was able to get this integral to be 2 over v minus 1 plus b over v minus 2 plus c over v minus 3 dv, and that would be twice natural log absolute value of v minus 1 plus, I would be and c terminal. I didn't copy those down. That's a 1 and that's a 1. So that would be plus natural log of v minus 2 plus natural log of v minus 3 plus c. Again, I could really combine those. There's no point. I am going to shrink this just a bit now that you've seen it. And that's the work required for this problem. Now, if I look at number 8, I notice this I could write as the sine of 2x divided by 2, or I could leave it as is. Well, I let u equal x, du is dx, and dv equal, either you leave it as the sine of x cosine of x, or the sine of 2x divided by 2 dx. If you integrate, v would be 1/2. The integral of sine is negative the cosine of 2x divided by 2. So this is going to give me u times v. That's going to be negative 1/4 x the cosine of 2x minus the integral of v du. So negative times a negative is a positive. There's a 1/4 up front. The cosine of 2x dx. That would be negative 1/4 x cosine of 2x plus 1/4. And the integral of the cosine of 2x is the sine of 2x divided by 2 plus c. That would be my answer. Next problem up, I chose number 26. Here, I'm going to let u equal the radical. I want to get rid of that radical. Well, if I take a derivative of that, I'm going to get x to the negative. You're going to bring the power of 1/3 down. It's going to be x to the negative 2/3, which is not there. So I know that I need to get an x in there, so that when I take a derivative of that, that's simply dx. So you cube both sides and get x to be u cubed. And when you take a derivative, that's 3u squared du. This becomes the integral, and this would be 1 plus u. dx is actually 3 up front, u squared du, and there is an x left, and that's where x comes in, and you would say that is u cubed, and that will be 3 the integral. This cancel 2 of those, you have 1 left over, du divided by u into u plus 1. So if you go on the side and say, well, that's going to equal a over u plus b over u plus 1. Let me shift this a bit to the right, and maybe I could do this here just to save space. So let me figure out 1 over u into u plus 1. If you want to bring the 3 in, you can, but it's better this way. 1 equal a into u plus 1 plus bu. Let u equal 0. You get 1 equal a times 0 plus 1 is 1. A is 1. This is 0, of course. Let u equal negative 1. That will be 1 equal a negative 1 there will make that a 0. Plus b times negative 1. That's a negative 1. So this in turn turns out to be 3 times the integral 1 over u minus 1 over u plus 1 du, and that would be 3 times the quantity natural log of absolute value of u, natural log of absolute value of u plus 1 plus c, and do we call that u was cube root of x, and that'll do the trick. When I get to this problem, I could really not pay attention and jump straight to the trick substitution and let 2t equal the secant of theta, but it would be wise to try a u sub first. If I let u equal 4t squared minus 1, du is 8t dt, divide by 8 both sides, that'll do the trick. This will be the integral of, there's my u, so that's the square root, the square root of u, and du is right there, t dt, that would be a 1/8 and a du. This is of course u to the negative 1/2, so if you add 1 to the power, right, that's u to the negative 1/2, add 1 to the power, that's u to the 1/2, divide by that, plus c, that would be 1/4 the square root of u plus c, and in this problem, of course, u was 4t squared minus 1. The next couple of problems I chose, 34 and 38. Here, obviously, this is integration, this is partial fractions. I'm looking at 1 over x into 3 minus x into 3 plus x, and that equals a over x plus b over 3 minus x plus c over 3 plus x. So 1 equals a into 3 minus x into 3 plus x plus bx into 3 plus x plus cx into 3 minus x, and the traditional, let x equals 0, 1 equal a times 3 times 3, that's a 0, and that's a 0. So I get a to be 1/9. Let x equal 3, I'll get 1 to equal a 3 in there, that will make that a 0, b times 3, and a 3 in there will make that a 6, and that's a 0. So if you divide both sides, b will equal 118, and if I let x equal negative 3, I'll get 1 to equal a negative 3 there will make that a 0, a negative 3 there will make that a 0, and c times negative 3, 3 minus a negative 3 is a 6, so that will make this negative 118. So this integral just became the integral of 1/9 over x plus 1/18 over 3 minus x minus 1/18 over 3 plus x dx. And if I eliminate those, just let me make that a bit bigger, 1/9 over x plus 1/18 over 3 minus x minus 1/18 over 3 plus x dx, and that in turn will be 1/9 natural log of x. This negative, if you let u equal 3 minus x, du will be negative dx, so that's minus 1/18 natural log of 3 minus x minus 1/18 natural log, and I'm going to shrink this and shift it a bit to the left, to the right, the other left. There it is. Shrink it a bit and move it a bit to the right. Absolute value of 3 plus x plus c, and that would be my final answer. Now when I look at number 38, I know I have a rule for sine and cosine, and if one of them is odd, in this case both of them are odd, you save one of them, it doesn't matter which one. Let's say you save a cosine of x dx. That means what you're left with is you took one of those, you have cosine to the 4th of x times the sine to the 5th of x dx. Remember, this is your du, so I'm going to have to really alter those and say that's the cosine squared, right? Cosine to the fourth of x is the cosine squared of x squared. And I know cosine squared is 1 minus sine squared of x, sine to the fifth of x dx, and a cosine of x dx. If I let u equal sine of x, automatically du will be the cosine of x dx. And as you see, this becomes a simple integral of 1 minus u squared times u to the fifth du. And that's simply the integral of 1 minus twice u squared plus u to the fourth u to the fifth du. And that would be the integral of u to the fifth minus 2u to the seventh plus u to the ninth du. And that's going to give me u to the 6 over 6 plus minus twice u to the 8 over 8 plus u to the 10th over 10 plus c. And if I substitute back what my u was, I didn't want for this to happen. U actually was my sine of x, and there it is. And a couple of more problems to go. Here I have secant tangent. We do have this formula for secant tangent. Let me see where it is. Formula sheet right there. So this is provided in the test. It says if tangent is odd, well, let's see. Tangent is odd. It says if tangent is odd, save a secant tangent. So we're going to save a secant tangent out of this. That's going to be your du. That means we still have a secant squared of x, and we have a tangent squared of x. I don't like those squares. I want to make them a bit bigger. Oops, wrong place. I can't touch the angle. If this is my du, what do you take a derivative of to get secant tangent? Secant. So obviously we're going to let u equal secant of x, which means we have to get rid of that tangent. And tangent squared is secant squared of x minus 1 times secant squared of x times my du, and du is going to be secant of x tan of x dx. And now if I let u equal secant of x, du will be secant of x tan of x dx. And notice it's right there. That becomes the integral of u squared minus 1 times u squared, and this in turn becomes du. And we know this is the integral of u to the fourth minus u squared du. I'm going to finish that off right there. And that's going to be u to the 5 over 5. Maybe I could just push that down a bit more. This way I have room for the other problem. So this is going to be u to the 5th power over 5 minus u to the 3rd power over 3 plus c. And what was u again? U was given to be a secant of x. Of course, you could write the secant to the 5th of x and the secant cubed of x if you wish. And let me leave it as is. And if I look at this problem, I notice there's an easy u sub. That is, if I let u equal e to the t, then du is e to the t dt. And let me not lose track. If this is my u, so square root of tangent squared of u plus 1 d e to the t dt, that's all of this, that would simply be du. There it is. And now I know what tan squared plus 1 equal. Let me think really quick. Tan squared plus 1 is actually the secant squared. And that will be the integral of secant of u du. It should be in absolute value, but here in this book, they seem to always assume that's positive. And we memorized, I asked you to memorize 3 integrals. That's natural log of secant of u plus tan of u plus c. And that will be natural log of secant. U was e to the t plus tangent of e to the t plus c. And that would be my final answer. And the homework for this portion is chapter review, page 533, 1 through 43. You could do the odd. You could submit every other odd depending on how much help you need on that section.